Okay, guys, so we're going to be starting off with or continuing on with our some new functional groups, specifically talking about aldehydes and ketones. So these are functional groups, or the first couple functional groups we'll talk about, that have carbonyl groups in them. So these are these C double bond O groups. Um, these are very similar to carbon-carbon double bonds, however, they're polar. So because oxygen is more electronegative, it holds those electrons in a little bit tighter to itself than the carbon, so that we have a slightly negative, a little bit more electrons on the oxygen and a slightly positive part with the carbon. And then again, remind ourselves of the geometry. The carbon is going to have 120-degree angle between all of the different substituents or different things around atoms around the side, because it only has 3 steric groups around it. So the functional group, that is when a carbonyl carbonate is attached to at least one hydrogen, is called an aldehyde. Generally, it looks like this guy here, where we have the carbonyl carbon and a hydrogen on one side, and then we have R on the other side. That could be a hydrogen, or it could be a carbon chain, whatever, what have you. And some examples of some aldehydes are shown here. And then additionally, we have our carbonyl carbon bonded to 2 carbons. That is called a ketone. Make sure you spell that correctly. And this is where you have that carbonyl and an R group on either side, where R has to be carbon. And here's a couple examples of some ketones. So you can have double bonds next to it, or triple bonds even next to it as well. Those are still called ketones. So let's go ahead and just get on it and start naming some aldehydes. So I noticed when I started this that I have a little bit of a typo here. So in your notes, just make sure it says that to take the alkane name and replace that alkane name, replace the E, not A-N-E, but replace just the E at the end with A-L. I'm going to put a dash there to show it's the end, A-L. Then you number the carbon chain, starting with that carbonyl carbon. Make sure you label that as a carbon, that's number 1. And then you name and number your other substituents, list them alphabetically. So let's look at our IUPAC for the naming system for these molecules down here. So in IUPAC, we start with the alkane name. So in this molecule, we just have this one carbon here. So the alkane name would just be methane. But we're going to drop the E and put AL at the end. So the name for this, according to IUPAC, is methanal. Okay, let's try the second one. Again, we are not going to number because there's no choices right here, but we have 2 carbons, so it would be ethane, but we're going to drop the E, so we have ethanol. Okay. Now we have our 3 carbons, so we do have to start numbering because there are choices here, or a little bit. Actually, no, we don't have to number because the aldehyde has to be on the end, right? So this is going to be called propane would be the parent chain, but we're going to drop the E and have propanol is the name for IUPAC. So again, we cannot put the carbonyl in the middle, because if we put the carbonyl on carbon number 2, then it's not an aldehyde anymore, then it's a ketone. So that's why we don't have to number it in this case. But if we were to number it because we had other substituents, let's do that. We'd have a number 1 on the carbon, number 2, and number 3. Okay, let's do this next one. We have our 4 carbon chain. 1, 2, 3, 4. We have, so that would be butane. We drop that E and add Al instead. Butanol. Okay, and this last one is a little bit weird in that because it has an aromatic ring, it's called something a little bit different. So I'm just going to go ahead and tell you the name of that, and that is benzaldehyde. So these in purple are all of the IUPAC names for these particular molecules. However, we're going to start also using common names for molecules too. These common names, as you'll see here, so we have our IUPAC names, we also have our common names. These common names end in aldehyde, and there are 5 that I expect you to know, and it's these 5 molecules here. So the common name for methanol is actually formaldehyde. It's kind of weird. You guys will be able to look at the chart and come back and find these, but memorizing them would just make things faster if you want to. If you have 2 carbons, it's called acetaldehyde. 3 carbons is called propionaldehyde. 4 carbons, I can never pronounce see, I told you. Butyraldehyde. Butyraldehyde. Got it. That is how that one. And then lastly, the IUPAC name and the common name for benzaldehyde is actually the same. Oh, wrong thing. It's actually the same, so don't have to memorize 2 different names for that one. Okay, let's do a couple practice molecules with substituents real quick before we get going. So this molecule here, we have 1. We're going to put our carbon 1 on our aldehyde. 2, 3, 4 is our numbering. So we would have butane, but we're going to drop the E and put Al. So we have butanal as our parent chain. And then we're going to put our substituents. I'm going to circle my substituent here. And I have 3-methyl. Ooh, look how close we got. Let's see if we can get in there. 3-methyl-butanol is the name of this one. Let's try another one. So we have our numbering. We're going to put number 1 on our carbon of our aldehyde. Number down the chain. So we have pentane. We're going to drop the E and put an Al. Pentanal. And then we're going to put our substituents on here. So I have just this 1 chlorine here. So 5-chloropentanal is the answer for this one. Okay, I will pick it back up and we'll learn how to name ketones. See you guys there.